Here are the answers for the Day 3 study guide over chapters 5 and 6. Question 1. Express the number in simplest form. Here we're practicing the exponent rules. There's a negative exponent, which means a reciprocal. So take that base and turn it upside down and give it a regular exponent, not a negative exponent. Then evaluate this as 16. Next one is very similar. For the ones that have negative exponents, make reciprocals. So the x to the negative 2 will move into the bottom, which already had x to the 3. Now it's a total of x to the 5. The y to the negative 2, which was in the bottom, will move up into the top along with the y to the 3, making y to the 5 in the top. Next one, write each as a rational expression. A rational expression means a ratio, one number on top of another. So this is 3 divided by x. Now it says determine any restricted values. X is in the denominator. A denominator cannot be 0, so that's our domain restriction. Number 13. This is already in a numerator and denominator arrangement, but we need to reduce this. So in the top, let's factor 5 times x plus 3. In the bottom, factor using FOIL. X minus 3 times x plus 1. Nothing in the top reduces or cancels with anything in the bottom. But by factoring it, it will help us get the restricted values. Remember that when there are variables in the denominator, we can't get 0. So the x minus 3 cannot turn out to be 0, and the x plus 1 cannot be 0. Now solve both of these. We get x is not 3, and x is not negative 1. Those are our restricted values for x. Next one, let's use factoring again. In the top, we have the w plus 2. But in the bottom, we can factor. This is 2 plus w over 2 minus w, because it's a difference of squares. W plus 2 is the same thing as 2 plus w, so that will reduce, just creating 1. Now let's get our domain restrictions. From that first factor, w cannot be negative 2, because 2 plus negative 2 would make 0. In this other factor, w cannot be positive 2, because 2 minus 2 would be 0. Next one, express each as a polynomial or a rational expression in simple form. This is basically saying to simplify. So let's start with our coefficients, 2 and 6. They reduce to 1 over 3. Now for the variables, use canceling or use the rule about subtracting exponents. We will get negative b over 3a. For the letter a in the top cancels one of the a's in the bottom, leaving one left over. For the letter b, the b in the bottom cancels one of the b's in the top, leaving one left over. Number 9, these almost match, but the bottom is the inverse of the top. So when you reduce these, it'll make negative 1 instead of positive 1. Number 21, let's use factoring and then try to reduce. So with FOIL, this is x plus 6 times x minus 1. And then in the denominator, we'll just copy down what we have down there. And now look for reducing. So it looks like the x minus 1's reduce, and the x plus 6 will knock away one of those x plus 6's. So we have 1 over x plus 6. Next one, we have a division problem. So let's follow the rule about division, which is to keep the first fraction the same, change to times, and take the reciprocal of the second fraction. Now look for reducing. The x minus 1's cancel, and 5 goes into 10 twice, so the answer is 2. Next one is multiplication, but this first fraction looks like it will factor, so let's do that first. We have x times x plus 3 over, and down here we can use FOIL, so this is x plus 3 times x minus 1. And then copy the other fraction down. And now look for reducing. So the x plus 3 cancels x plus 3. This x cancels this x. And the final answer is x plus 1 over x minus 1. This next one is a division problem again, so we want to follow that rule about changing to multiply. At the same time, we need to do some factoring. So this is 2 times z minus 4 over z plus 2 times z minus 2 times, I'm going to flip this fraction upside down, and at the same time, I'm going to factor that trinomial. So this is z plus 4 times z plus 2 over z minus 4. Now look for reducing. The z minus 4's go, and the z plus 2's go, and I think that's it. So final answer is 2 times z plus 4 over z minus 2. The next problem is simplifying. It still involves fractions, and it's about adding and subtracting. So we need common denominators, which all the fractions already have. So the rule to add and subtract fractions with common denominators is combine the numerators and keep the denominator. 3 take away 7 is negative 4. Negative 4 plus 11 is 7. The answer is 7 over 5. Number 7 is the same thing, but it doesn't have common denominators. So the lowest common denominator you can make from 3a and 12a is 12a. So to make 12a, you times by 4 and times by 4. This becomes 8 over 12a plus 7 over 12a. This makes 15 over 12a, which now reduces because top and bottom both divide by 3. So final answer is 5 over 4a. Number 9 is the same thing. Subtracting fractions, you have to have a common denominator. So between a 3 and a 2, the lowest common multiple is 6. Between an x and an x squared, the lowest common multiple is x squared. So this one here needs to be multiplied by 2x in order to make 6x squared, and in the top. This fraction here needs to be times by 3 in order to make 6x squared, and in the top. So this is 14x over 6x squared minus, and then 6 over 6x squared. Now combine like terms. 14x minus 6 all over 6x squared. Now let's factor the top. 14 and 6 both divide by 2, getting us 2 times 7x minus 3. That's all over 6x squared. Now we can reduce the 2 and the 6. We get 7x minus 3 all over 3x squared. Number 11. Adding and subtracting fractions, we need to have a common denominator. So between 3, 2, and 12, use 12. These have n's in them, so you also need an n. This can be turned into 12n by timesing by 4. This can be turned into 12n by timesing by 6. And this one here, you just need to times by n. So now let's rewrite. We have 32m over the 12n minus 6m over the 12n plus n over the 12n. Now combine the tops together. 32m minus 6m is 26m plus n all over the 12n. And here's the simplified version. Next problem, subtracting fractions. So we need common denominators. Let's first factor these to help us get the common denominators. So this is t plus 4 over 2t times t minus 1. And then minus, this other one is 5 over 2 times t minus 1. I can see that the common denominator needs a 2, a t, and a t minus 1. This almost has that. It's only missing the t. So times top and bottom by t. Now they both have the same denominators. So we have t minus 5t, which is negative 4t, plus 4, all over our common denominator. The top will factor. We can factor out negative 4. And now we can reduce. These cancel away, and 2 goes into 4 twice. So final answer is negative 2 over t. This next one is called a complex fraction. The technique to solve this is to multiply everything by the denominator that you see in there. That denominator is a squared. So you want to times everything by a squared. In one spot, the a squareds will cancel away. That's what removes that extra denominator. So now we have a cubed minus 2a squared all over a squared minus 4. Now let's factor. This is a squared times a minus 2. The denominator is a difference of squares, so it makes a plus 2 times a minus 2. And you'll see the reducing now. These go away. So a squared over a plus 2. Next one, same idea. This is a complex fraction. Let's multiply everything by the LCD. So look at all the different denominators. Between a 3 and a 5, the LCD is 15. And then there's also an S, there's also a T. So our lowest common denominator has to have a 15, an S, and a T. Times everything by that. Some stuff will cancel. The S will cancel the S. The T will cancel the T. 3 goes into 15, leaving 5. 5 goes into 15, leaving 3. Let's rewrite. 3 times 15 is 45t. 5 times 15 is 75s. 3 into 15 is 5, so this becomes 5s squared t. And 5 into 15 makes 3, so this becomes 3st squared. Now let's reduce. 5 will go into, 15 will go into 45 and 75. So we have 15 times 3t plus 5s. In the bottom, we can divide an s into both and a t into both. So factor out st. We're left with 5s plus 3t. When you try to look for reducing, notice how this right here matches this right here. So they cancel away. The final answer is 15 over st. Next, determine the solution set of the equation. We have an equation with fractions. So the technique is to multiply everything by the LCD. That will remove the fractions. With a 3, a 4, and a 2, the smallest number they both go into is 12. So times them all by 12. 3 goes into 12 4 times, this makes 4x. 4 goes into 12 3 times, this makes 3x. 2 goes into 12 6 times, this makes 42. So 7x equals 42. Therefore, x equals 6. Next one, same idea. The lowest common denominator of the numbers 12, 9, and 36 is the number 36. So let's times this first one by 36, and then times this by 36, and then times this by 36, and this by 36. 12 goes into 36 3 times. So that 3 will get times to these two things with the distributive property. We have 6c minus 45. 9 will go into 36 4 times. Notice the minus here. So let's take a negative 4 and times it to those two things. We get negative 12c minus 8. 36 and 36 reduces just to a 1. So we get positive 6c and plus 53. And 0 times 36 is still 0. Now let's do some combining like terms. The 6c and the 6c cancel away. Looks like we have negative 12c left over. Negative 45 and negative 8 is negative 53, which combines with the positive 53 to make 0. So those cancel away. Divide both sides, and you get c equals 0. Next one's very similar. We want to times by the LCD. So in the denominators, between 2 and 6, use 6. And there's even some x's, so you need an x. So times by 6x, times by 6x, times by 6x. The x's cancel, leaving 6. 2x goes into 6x 3 times. And over here, the 6's cancel, leaving x. So we have 9 is equal to x. Next one. We can use our same technique about timesing by the lowest common denominator. Or, because this is in the setup for a proportion, we could use cross multiply. Either way will work. I'm going to use cross multiply. 4 times the 4m plus 3 is equal to 3 times the 3m plus 11. Now the distributive property. 16m plus 12 equals 9m plus 33. Subtract 9m from both sides, you get 7m. Subtract 12 from both sides, you get 21. Therefore, m equals 7. Okay, now we're back to an equation, but this time it does not have the look of a proportion. We can't use cross multiply. First thing I'm going to do, though, is I'm going to factor things. So we have 2 over y plus 2, and then plus y over y minus 2 equals y squared plus 4 over y plus 2 times y minus 2. This helps me to figure out my lowest common denominator has a y plus 2 and a y minus 2. So times the first one by that denominator. And times in here by that denominator. And over here by that denominator. Now the canceling. These cancel. These cancel. And these cancel. So we have 2y minus 4 plus y squared plus 2y equals y squared plus 4. There's a y squared on both sides, so those will cancel each other away using subtraction. 2y plus 2y is 4y. Let's add 4 over to the other side to make 8. And now solve and we get y equals 2. I notice though that 2 is a restricted value. Right there, if y was 2, then that denominator would be 0. So because that's restricted, you have to cross it out. We have no other answers, so we put empty set. Next one, give the range and draw the graph of the following equation using those numbers for x. So let's make an xy chart and fill in all those numbers for x that we're told to use. Put it right there and evaluate that function rule. Negative 3 minus 1 is negative 4. Negative 2 minus 1 is negative 3. I think I see the pattern. We're asked for the range. The range is a list of all the y values that we got. So negative 4, negative 3, negative 2, and so on. All the way up to 2. Now we're asked to graph this. I noticed that one of the numbers I got for y was negative 4, so I have to have that many marks on there. And I made it all the way up to positive 2 as the highest value of my range. So left 3 down 4, left 2 down 3, and so on. Next one, same idea. Let's make an XY table and use all those numbers we're told to use for X. Substitute them in right there. So 1 minus negative 3 makes 2, and the absolute value of 2 makes 2. 1 minus negative 2 makes 3. Whoops, I think I made a mistake on this one right here. Let's go back and fix that. We got the absolute value of 1 minus negative 3. That's equal to the absolute value of 4, which makes 4. Okay, now this one. The absolute value of 1 minus negative 2 is equal to the absolute value of 3, which makes 3. This one here turns out to be 2. This is 1. This is 0. Then we have the absolute value of 1 minus 2, which makes the absolute value of negative 1, which is 1 again. So the pattern starts to count back up. This next one will be 2. So for the range, the lowest answer we ever got was 0, all the way up to the highest answer of 4. Now the graph. Negative 3, comma 4, negative 2, comma 3, negative 1, comma 2, 0, comma 1, 1, comma 0, and then it started to go back up. Next one, state whether this is a function. Notice this dot here and this dot here lined up with each other vertically. That is not a function, because that x value of negative 1 has 2 different y values. Number 3 does not have anything like that. There's no spot where the graph has a dot lined up vertically with another dot on the graph. This is a function. In the last one, we're asked to give the domain and the range. We're also asked to give the domain and the range if it's a function. So the domain is all your x values. Right there is as far left as it goes, negative 2. And right there at positive 2 is as far right that it goes. So the domain is that x is in between negative 2 and positive 2. Now the range, where's y? Well, right there at negative 2 is the lowest spot on the y-axis that the thing ever reaches. And this dot lines up with positive 2, the highest spot it ever reaches. So y is in between negative 2 and positive 2 as well. Next one, is this a function? No, it's not, because when x is 3, there are 2 different y values. If you were to graph those dots would line up vertically. It's not a function when that happens. Next, we have a function rule, and we're asked to evaluate p of 2. So you substitute in 2 and find the result. 4 minus 4 is 0. 0 plus 1 is 1. Next, we're told that this is a function and we're asked for the domain. Well, the domain is a list of all of your t values. Whoops, sorry about that, not your t values. All your input values, your x values. So all of your x values are 1, 2, 3, and 4. Now we want to write a formula for t of x. The first thing I notice is this is linear. There's a constant rate of change from dot to dot. That slope is 6, because this is changing by 6 when this changes by 1. The other thing I notice is there's a point, 1, 7, that's a solution. So we can use point slope form. Y minus y1 equals m times x minus x1. It's not really y that we're talking about, right? It's the letter t, but we can still use that pattern. So y minus 7 equals 6 times x minus 1. We can leave it like this, but we're not really talking about y, we're talking about t, so we really should fix that. We have y equals 6x plus 1, and let's replace y as t of x. Next one, find this composition where you put one function into another function. So work from the inside out. You first need to find t of 2. So put a 2 right there. 2 plus 1 is 3. 3 squared is 9. So this number that's right in there, that's a 9. So we're now finding r of 9. So right there, fill in 9. So 3 times 9 is 27. 27 minus 1 is 26. Next one, we're told that y varies directly as x, and we're given some values. So if y varies directly with x, let's compare y to x using ratios. Y is 30 when x is 5. What's y when x is 15? I can see that y is 6 times bigger than x, so y is equal to 6 times 15, which is 90. Next one, 2 grams of hydrogen unite with 16 grams of oxygen to make water. So how many grams are needed to produce 144 grams of water? If we compare the grams of oxygen to grams of hydrogen, we have a 16:2 ratio, which does reduce to 8/1. The point is that the weight of the water is 8 times bigger than the weight of the hydrogen. So we don't know how much hydrogen we have. Let's represent that with the letter H. And we don't know how much oxygen we have, but we know that its weight is 8 times bigger than hydrogen. We can represent oxygen with 8H. That's the hydrogen. That's our oxygen. When you add these together, you get a total weight of 144. So this makes 9H equals 144. Now divide both sides by 9. And H equals 16. We were using the letter H to represent the grams of hydrogen. Remember how the grams of oxygen were 8 times more than that? So 16 times 8. That's 128 grams. This is our oxygen. This one's how much hydrogen we have. Number 8, when water freezes, it expands 9% of its volume. How much water must freeze to form that many cubic centimeters of ice? We don't know how much water we need. Let's represent that, maybe with the letter X. But we're told that when you freeze it, it expands 9%. So we can multiply it by 1.09. And that's supposed to turn out to be 545. So divide both sides by 1.09. And we find out that we need 500 cubic inches of water to begin with. Next one, graph this piecewise function. First, let's build the axis system. Pay attention to this part right here. It describes the x-axis. We're going to have parts of our graph that are less than 0. So from 0 to the left. Let's put some marks going to the left. We're also going to have a part of our graph where x is greater than 0. So from this point to the right, let's put some marks to the right. Now let's look at our y-axis using these numbers here. What's the lowest number you ever have? It's -1. So at least put -1 on there. You can put more marks, but they're not necessary. What's the highest mark you ever have? +3. So at least get up to that. Now, when are you at a height of +3? Whenever x is less than 0. So mark that with an open dot and draw to the left. Now this middle row is a single dot. It's at 0, 0. The last row is that you're at a height of -1 whenever x is more than 0. So mark it with an open dot and draw to the right. Number 8, very similar. Let's first build our axis system. Take a look at this information here to see what's going on the x-axis. X sometimes is between 0 and 4, so we at least need to get to 4. And then in the next part, x is greater than 4, so it starts at 4 and continues to the right. Let's put some marks farther to the right. We can put marks to the left, but it's kind of a waste of time. Now let's take a look right here to see what to do on the y-axis. But realize it's not actually y, it's called f of x. It's the same thing as y. Sometimes we have a linear equation that has a slope of 1/2. We're going to be going up 1 over 2, up 1 over 2, and so on. Other times we're just going to stay at a height of 2. So I don't really see any need to have anything negative showing. Let's put some marks going up and start graphing. When do we have the diagonal line? When x is between 0 and 4. So start where x is 0, mark it with a closed dot because of the little bar, and go up 1 over 2, up 1 over 2. Now when you get to 4, you have to stop. Notice how that does not have a little bar on it? So that's an open dot. Here's our diagonal piece. Now what happens from 4 and going to the right? We stay at a height of 2. So you draw. So when x is 4, you put a dot at 2, in a sense filling in the open circle you just had, and then go straight over to the right. Next one, graph two functions on the same coordinate plane. Let's get some marks on there. And focus on this first one. With no x term and no constant term, the vertex is at 0, 0. Then look at the value of a, which is -5. So when x changes by 1 unit, you drop down -5 units. And draw in a U-shaped parabola. Now this other one, it also has no x term and no constant term, so its vertex is at 0, 0. Now look at the value of a. It's also going downwards. When x changes by 1 unit, you only go down 1/5, just a tiny bit down. So this makes a much wider opening parabola. Next, find the value of a in this equation if this is a solution. So this is your x, this is your y. Let's make those substitutions. 6 equals a times 3 squared. So 6 is equal to 9a. Divide both sides by 9. You get 6 over 9, which is 2/3. Next one, graph both of these functions on the same coordinate grid. These are both in vertex form. This is A, this is H, this is K. H is +1. H is the number after the minus sign. So for your vertex, it's H comma K, 1 comma 4. Then look at the value of A to get more marks. You can see already I'm going to need some more marks going up on this. When A is 2, you go over 1, up 2. And draw in a U shape. Now let's go to this other one. This is A, this is H, this is K. This time K is -4. So the vertex is 1 comma -4. But the value of A is still 2. So over 1, up 2, and here, and draw in a parabola. Next one, graph this one. This is in standard form. A is 1, B is -3, C is 4. So this time, to get the vertex, you use the formula -b over 2a. So this becomes 3 over 2, or 1.5. Now to get the y value of your vertex, take that answer 3 over 2 and plug it into the equation. You might use a calculator to help. This is 1 3/4, assuming I typed it in right. So the vertex is over 1.5, comma 1 and 3/4, about right here. Now the value of A is 1, so go over 1, up 1, left 1, up 1, and draw in a U shape. Number 12, graph this one. This one will have a dashed boundary line, and you will shade under because of this arrow. But the boundary line is a parabola. This parabola has an x squared term, no x term, and a constant term. So the vertex, instead of at 0, 0, will be up 1 unit because of that extra plus 1. The value of A is still positive 1, so you go over 1, up 1, over 1, up 1, and draw a U shape. Remember we said it would be dashed. And shade under.